Thanks everyone who's submitted the Module 2 assignments so far. Apologies if we haven't got around to marking yours just yet. We'll certainly get that feedback over to you shortly. I might just share my screen to show you a specific detail about this location. So if you haven't done the assignment yet, please don't use this little example as part of your assessment. I'd like it if you've got your own ideas and things like that, but just thought I'd demonstrate something. So our content for today is going to be focused on bicycle infrastructure at intersections. And there's a common intersection risk that I wanted to make a note of that is exemplified in this design example. So at the corner of York Street and Wellington Street, so right at the southern end, I guess you could call it, we do have a signalized intersection. And because York Street is one way, we've only got traffic obviously heading westbound, southbound. And we've got the bicycle lane that is proposed on the curb side there. Now I've got some handy little figures that I'm going to drop and copy in place just to demonstrate a risk that I'm concerned of with this arrangement. So I've got some green vehicles that are on the inside lane. And then I'll put a reddish orangey vehicle approaching the signals on the outside lane there. And I've also got my bike rider coming through as well. So something like that. And let's just pretend like the signals, they were stopped, but now it's just going to be green. So now they've got the green phase and there's no separate phase for the bike rider. It's just green matching in with the general traffic as well. If we have a look at our stand-up lane turning configuration, we can see we've got a dedicated left lane and we've also got a through and left. In other words, you could turn left from both of those lanes. And that's the issue that I'm concerned about because a bike rider may want to carry on through like this. Change that to a different color there. Whilst that's occurring, the inside vehicle may want to turn left and the vehicle on the outside may want to turn left as well. And you can see just by this arrangement, it's very, very difficult for that vehicle on the outside to be actually able to see the bike rider. It's what's referred to as either masking. The inside vehicle masks the outside vehicle, obstructs their sight lines. Another term for that is dynamic visual obstruction, quite a fancy term. But basically, whenever you've got dual turn lanes, like we've got here, you've got that risk of one of the vehicle lanes obstructing sight lines for the adjacent vehicle. And where you've got a bicycle lane there as well that's trying to do a through movement, there's quite a significant conflict point there and a heightened risk level. So that's one of the issues that we have with intersections. It's certainly elevated when you've got more than one turn lane, as we can see here, but just thought I'd demonstrate that in like a semi-real environment. Anyway, we'll go back to our content for today. And as mentioned, we will be chatting through intersections. Before we get stuck into some content though, just a bit of a reminder, we will be counting our Wallies again. So we've got a quiz at the end of today. So make sure that you are keeping track of how many times you see Wally. And hasn't been any so far. So you haven't missed any. You're not out of time just yet. You're currently at 0. A few other bits and pieces I wanted to cover. We didn't get time in our last session to discuss how we can manage protected bicycle lanes around bus stops. One of the preferred treatments within this environment is what's referred to as a floating bus stop. So that's what we've got here. This is actually in Manchester in the United Kingdom. And from the aerial, might be easier to see what's going on. The bicycle lane kind of gets offset and pushed behind the bus shelter. So it means that pedestrians that are waiting for their bus and they're hopping onto the bus, or they're just leaving the bus or lighting the bus, they're not stepping onto a bicycle path. There is that separation. The other good practice thing to do in this environment is to create designated crossing points for your pedestrians so that it's not just a open permeable space, but trying to, I guess, encourage pedestrians to cross at specific locations to access those bus stops and bus shelters to be able to wait for that. Very, very good solution. It's much better than just having to wait behind a bus, and just wait for them to pick up and drop off all their passengers before you get to go again, or you have to kind of push yourself out into live traffic to overtake the bus. Both of those are not great scenarios. This is a preferred arrangement. I've also got this example. This one's down in Geelong. And in this instance, there wasn't quite the width available to be able to offset this path to bring it behind the bus stop and the bus shelter area there. It's just too narrow a space to play with. So instead, what has been installed, the protected bicycle lane, this is bi-directional, as you can see. They've got a straight travel path through here, but in order to raise the awareness of that conflict point, you can see that we've got that raised feature. So there's like a little bit of a hump there in the middle. It also improves the accessibility for pedestrians because they're not having to, step down onto the bike path and then step back up onto a bus or anything like that. It's all kept level at the footpath level, but bike riders are forced to kind of yield. As you can see, there's give way to pedestrian signage there. And the vertical deflection will do a very good job at just making it much more conspicuous, the conflict point there. Another treatment that we didn't get across last week was this idea of a bicycle boulevard or advisory bicycle lanes, safe, active streets. There's lots of different titles for this type of treatment. And the basic premise is rather than permit kind of two traffic lanes, so one traffic lane in one direction, one traffic lane in the imposing, and then having no cycling facilities, instead creating dedicated cycling facilities going both directions and just having one shared traffic lane. So you would only do this in urban residential settings where you do have low speeds, low traffic volumes, less than a couple thousand vehicles per day. You don't want to be, encouraging drivers to be using this or anything like that. That's not the point of it. It shouldn't be used as a thoroughfare, but it can work quite well, and it can be one of those other, local area traffic management treatments to support cycling if you don't have lots of money to be doing protected bicycle lanes and things like that. Here's an example of one out of Canada. And that's the signage that they use, I guess, to communicate that to drivers, that motorists do need to yield to riders that are in that bike lane. But just the width of that traffic lane, as you can see, it only permits one travel direction at a time. A few years ago, we had one of these installed in Victoria. So this is Napier Street in Fitzroy, for anyone that's interested. And because this is a novel treatment, there was a bit of media and communications that went out, and they developed this video just to explain basically how to drive through this area. So in this instance, we've got a blue vehicle at the bottom of the screen, and you can see it's traveling in the shared traffic lane. And then a moment forward in time, they can see that there's an oncoming vehicle. It's both of their responsibilities to slow and give way to any bike riders that could be in the riding facility. Then when it's safe to pass one another, there is enough, room there to be able to safely pass without any clipping or anything like that, but utilizing part of the bike path. So this one has been installed since, and it is another example of lots of local area traffic management treatments, speed humps and things like that to slow down vehicles, and signage as well to demonstrate that this is a cycling priority route. I also briefly touched on how Portland in Oregon, they kind of manage their cycling networks in residential streets. So they don't have the protected facilities. They do use lots of shallows, but they close off intersections periodically so that they're getting all vehicles back onto the arterial. That's kind of the vehicle corridor. And then the cycling corridor is the parallel adjacent one. So that's just an example of that kind of modal filter where vehicles cannot travel through there, but it's quite easy for bikes to get through there. Just thought I'd give you a little snip of what that one looked like. Hopefully everyone had a chance to review the 360-degree footage. We did have two examples of riding in different on-road infrastructure. So the first one was the protected bicycle lane, and then the second little snapshot was riding adjacent the dooring zone. So if you've never actually ridden on road, you've never had the experience of riding adjacent the dooring zone, hopefully that gave you a bit of perspective of what it can feel like and how stressful it can be, particularly if you've got busy traffic behind you. You do feel like it's a perceived level of risk. You do feel quite unsafe in those environments. Now, to focus on today's agenda. So, as mentioned, we will be discussing how we can manage the safety for our bike rider community at intersections. Intersections for a long time has been considered the weak link in the chain. So it's kind of the highest risk area for bike riders along cycling corridors. And the reason for that is because we've got lots of conflict points. So that's where vehicles are crossing, and there are lots of vehicles. So there's lots of exposure to that conflict. And so we're going to be looking at ways that we can reduce the risk associated with those conflicts and what we can do to mitigate those. A lot of the guidance that we will be looking at today is an international reference. So this is from NACTO. They're like I guess they're similar to an Austroads out of North America. They've got lots of different jurisdictions that kind of sign up and they sit down together and work out what's best practice. And they've got a very appropriately named Don't Give Up at the Intersection that talks a lot about what we can do at signalized intersections to improve the safety for bike riders. We'll also have a chat through more conventional signalized intersections and what other treatments that we could use to reduce the risk. So a protected intersection would be considered kind of the gold standard. That would be our ideal scenario. But we'll also have a chat through what other treatments are available and some of the underlying risks associated with those ones. But the first point of call, I did want to focus on this idea of a protected intersection. So I'll chat through the design specifics of the protected intersection. I'll show you through some international examples, as well as Melbourne's protected intersection. Melbourne's not the only jurisdiction to have protected intersection. There's a few up in Queensland. likely others dotted across the country. So they're becoming more prevalent, but by no means are they the standard. And there's a bit of work in getting the communication around what they are and how they work. So that's what we'll be focusing on today. So protected intersection looks something like this. This is an artistic rendition of Melbourne's protected intersection. And at this stage, what I'd like you to focus on is just at the corner or quadrants. I refer to this as the quadrant of every intersection. There's these little kind of build outs or raised features. They're referred to as corner refuge islands, and they have a very, very important function that we'll certainly be talking a lot about today. But just to demonstrate how this works if you were riding through this environment, let's say you wanted to turn right coming from the bottom of the screen, you would be positioning yourself at this stop line. You then get your phase, and it generally runs concurrently with the adjacent traffic stream. So that traffic traveling in the same direction as you and also turning left, they tend to be running at the same time. Or you might be given a head start. When that's green, you're good to go. And if you're interested in turning right, again, you have to pause and wait at your hold line. So you've got your own little hold line there. And you wait for your green phase to go, and then you continue your journey like that. So you're not being forced to kind of enter the roadway or the specific carriageway. Like, you are still protected away from that area. And there's a reason that all of this is occurring, which will make more sense as we look into it. So conventionally, the way that our typical intersections are arranged is we have our cycling facility directly adjacent to our left turn traffic lane. That's the most common way that we do things. We just have a bike lane that's on the curb side and then a left turn traffic lane adjacent that. The fundamental issue with this approach is if we've got riders that are traveling through and we've got vehicles that are turning left, the sight lines there just don't work. It's very, very difficult to be able to see a bike rider that could be on your passenger side door or behind you, because that's where the blind spots of the vehicle are. So it's very, very difficult to manage that from a sightline perspective. And the sight lines here are represented by that triangle. So that's kind of where the driver is focused. And if I clear all of my little scribbles now, you'll see in the conventional intersection, the driver is not focused where the conflict exists. And you can see the bike rider there could be hidden. Of course, our road rules do state that if a bicycle rider does see a vehicle that's got their left indicator on, then they have to slow down and yield. That's, I suppose, the legal way of looking at things. But there's several instances where a driver may not be using their indicator, or they may put it on at the last second. There's a myriad of reasons why we can't just rely on our road rules to protect our bike riders. Instead, we can look at, well, what infrastructure can we have in place to better support the safety of our riding community there? And that's where the protected intersection enters. So what we are doing is we're increasing the distance from where the cycling path is to where the left turn traffic lane is. So I've referred to this as the offset. Offset is just the distance or the clearance, the width, whatever you want to call it. Distance in between that left turn traffic lane and where the bike path is. The reason that we're maximizing that offset is so that we are maximizing our sight lines. So you can see that sight triangle. It's much easier for that driver to be able to see riders as they're crossing over in front of them. They're no longer crossing on their passenger side behind them. Much, much more visible. So that's the key benefit of the protected intersection. It's really to mitigate the risk of left turning vehicle traffic and through bike riding traffic. And the way that this arrangement is, I suppose, self-enforced is through the provision of this corner refuge island. If we didn't have that in place, it'd be very easy for vehicles just to kind of cut the corner, and that would significantly reduce the effectiveness of this treatment. So the corner refuge island is there to tighten up that turning movement and to ensure that vehicles are taking this kind of swept path movement, not cutting the corner there. This one's out of TMR, selection of and design of cycle tracks. And once again, we see the comparison there of a conventional intersection versus a protected intersection. So with the protected, you can see the corner refuge islands have been installed again. They're a critical feature. If you're a bike rider and, traveling up north there, and there's a vehicle that's turning left at this location, you can see that conflict points where those two paths connect, it's pretty bang on perpendicular. So it's very, very close to 90 degrees. And we know if we are able to get conflict points as close to 90 degrees as possible, we've maximized our chances of visibility. We're improving our sight lines there. In a more conventional intersection, you'd have something like that. That one actually looks pretty good because my drawing was bad, but it's usually a more acute angle. So it'd be more like that. Sorry about my poor drawing. This becomes an even more significant issue when you have things like skewed intersections. So in the left-hand example, we've got an intersection that's not quite like a cross. It's got an angle to it. And that can make seeing through cycling traffic even harder as you're trying to do a left turn to get around there. So there's another instance of where the protected intersection can help to facilitate and make that crossing journey safer for bike riders. The details of a protected intersection, there's a few kind of key elements. This has been adopted from the American reference document, so from MassDOT. So apologies if the terms and the exact figures look a little bit odd, but I'll translate it. I'll get everything across. So the corner refuge island, that is number one there. And as I mentioned, that's there to ensure that we've got our traffic as they're performing their left turn movements, they're using that device to delineate their path. Without that, it's very likely you just get drivers kind of cutting the corner and traveling at relatively high speeds. So very, very important feature of the protected intersection. The next one is forward bicycle queuing area, number 2. We'd probably just call this a storage area. This is just the area for bike riders to prop and wait for their phase. Depending on your specific environment and how much cycling demand there is expected, you may have to make edits as to exactly how much area to allow for cyclists to store there. There's no real specific guidance to say it should be 2 meters if there's 20 bike riders during peak hour or anything like that. It will have to be kind of resolved more organically than that. Number 3 is the motorist yield zone, or just where the vehicles give way. Number 4 is a pedestrian crossing island. And the reason that this is kind of brought into it is just to encourage all practitioners and designers that it might be easier to create a shared crossing experience. So just have bike riders and pedestrians cross as one unit through here. But it's definitely preferable to separate those two users, particularly if before that intersection you had separate facilities. So you can see there's a dedicated protected bicycle lane there, and then there's a adjacent footpath. It's good to maintain that separation through the intersection as well, and not just combining it. So that's why that's been implemented there. Number 5, and this one I've touched on a few times, and something that I am definitely supportive of, is the idea of pedestrian priority across the bike lane. If you're a pedestrian and you're used to walking at signalized intersections, you're absolutely very, very, I don't know, trained, indoctrinated to leave your footpath, get the green, and then continue all the way to the other side until you hit the other footpath. In other words, it's likely you're going to be crossing that bike path at number 5. It's likely you're already very inclined to want to do that because it's just, you will assume you have priority. It'd be almost counterintuitive to say, stop, give way to pedestrians, as in pedestrians, you need to stop and give way because bike riders come through here. That would be a very difficult thing to be able to communicate to pedestrians. So instead, strongly encourage you just to award the priority to pedestrians to mitigate that as a risk. So you're going to have bike riders yielding to pedestrians crossing over the bike path there. It's a little bit more intuitive for bike riders because, you know, they're at a signalized intersection, and also if they're seeing the zebra keys or the zebra line markings, it's pretty clear that they need to give way there. So that's a very good tip. And number 6 is, curb ramps, pram ramps, just to make sure that you're facilitating that travel and you've maintained your accessibility. All right. It's always best to chat through these with some examples. So I've got a site here out of the Netherlands, and this is a conventional intersection that has since been upgraded to a protected intersection. And I just thought I'd show you the before and after. The leg that I'm going to focus on is the northern leg, so kind of top of the screen. And I'm going to focus on a bike rider that's traveling south. They want to do a through movement. And then I'll also draw the movement of a vehicle wanting to turn left. So first off, I'll just make a note. That little dot, 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 that's the bicycle lane. And that is where we'll position our bike rider. So that's just like a, curbside on-road bicycle lane that was previously provided. If you're riding through here, you'd be riding close to the curb, doing something like that. And if this was in a free flow state, meaning there's just green lights, a vehicle could be coming and turning left, looking around and doing that. Now, that's a much better drawing to demonstrate that we've got quite an acute angle there where the conflict point is. So we've got 2 conflict paths and it's a very acute angle. We know that that's not going to be good for sight lines. So even if you put yourself in the perspective of that vehicle turning left, it's, unless you've got prior sight lines of that bike rider, it's difficult to be able to see them where that conflict point exists. this is what it looks like now, and I'll do the same exercise and just draw how each of those modes travel through this intersection. And the bike rider, they kind of get quite a generous off-road style path, and they've got a little hold line there. It's also much further in front of the hold line of the vehicles, which is good. Once they get the green, they'd be able to carry on their journey heading southward. But let's say that there was no need to stop and it was another free-flowing condition. Then both of those users would be going, and where the conflict point is, you can see we're basically perpendicular. So it's much, much easier for that left turning vehicles to be able to see crossing bike riders. And this is what it looks like actually out on the ground. And I'll give a prize out. If anyone can tell me anything that looks unusual about this site, nothing to do with signage, but anything that looks a little bit odd associated with this site, or something that we wouldn't do perhaps within our jurisdictions. Okay. Give you 15 seconds to give that a go.
I'm going to say that surely the wombat. No.
I didn't hide that very well, did I?
It's a tough one to ask the question of what's wrong with this site. What do we not normally see? Okay, we've got uneven surface, riding, driving on the other side of the road.
Any other
Is that because
punters?
it's an international example and that's what they do there?
Yeah. All right. Well, the one that I had in mind, both are accurate. Traffic lights for cyclists. Same color surface. That is odd. I agree. The same color surface. But the one that I was alluding to a little bit, or one I kind of identify as unusual, is the carriageway level and the level of the footpath. It's all the same thing. Like there's no curb difference, no curb heights or anything. I think this would not work particularly well in our jurisdictions because, and also because it's the same color, you would get vehicles just driving over that area that's meant to be for cycling queuing or pedestrians to wait. They would quite easily mount that, which is not an ideal scenario. So we would be doing curbs just to make sure that we're clearly delineating where the edge of the roadway exists, where the edge of the traffic lane is. But this is the Netherlands, and I guess they're used to seeing bike riders everywhere and perhaps driving a bit more courteously. So that's just an example of different jurisdiction there, Kathy.
Good.
Give you another international example. This one's out of Maryland in the USA. And we've got a little design here showing the protected intersection. And we've got two different materials being proposed for the corner refuge island. So if we have a look at this gray material, it's saying it's a proposed concrete or proposed stamped concrete. I'm not sure which one it is. And then adjacent that, we've got a proposed brick material. Here's another one for the group. Any reason that you can think of that we may have, oh, I can see it in the chat already. I didn't even finish the question. The reason that we would have different materials there is because we do need to ensure that we are providing adequate swept path movements for heavy vehicles. So if you've got buses or maybe the largest vehicle you need to provide for is like a fire truck or a garbage truck or something like that, we still need to make sure that we are not implementing these curbs and things like that that could affect their ability to actually travel in this area. So the way that this one works is the grey stamped concrete for this design, that's at the roadway level. And then the proposed brick, that is at an elevated kind of curb height level. What we want to see is general passenger vehicles. They will use the stamped concrete as like the edge of their path. Whereas heavier vehicles, longer vehicles, when they go to turn left here, they can make the most of that space that's available and yeah, still be able to safely perform those turning movements. Here's what this site looks now that it's actually being constructed, and hopefully you can see what I'm talking about. Maybe it's easy if you look in the other side of the intersection, you can see that that is the concrete section. It's also referred to as a mountable apron. We install those at roundabouts and sometimes rural intersections and things like that. So it's got a mountable apron there, but we've also got this other level, which is the brick that we were talking about, and that's been raised. So two different levels there. Another interesting thing about this site, and I'll go back to my previous slide, is we do have a bi-directional facility just on one side of the intersection. So you can install protected intersections with bi-directional facilities. It doesn't have to be one way. And you can also manage intersections that kind of have both forms of travel. Yeah, so just wanted to shout that out as well. And this is how it, looks with that bi-directional. We don't do that kind of pavement marking. That's just the American standard there.
Max, sorry, just a quick question for
Yeah.
you. How does it impact with the line of sight, especially with bigger vehicles?
It's a good question. So bigger vehicles, heavy vehicles, they have an even worse sight line availability than passenger vehicles. They've got much, much more blind spots and areas where a bike rider could be hidden. The protected intersection would still offer advantages for heavy vehicles as they're turning left, because you've still got the bike rider hopefully coming through the, basically the windscreen area as opposed to the adjacent, passenger side area. So there's definitely still improvements, but I'd be more leaning towards if you're on a route that has lots of heavy vehicles and they are performing left turns where you've got another route, which is a cycling corridor, and they're going straight, I'd be much more confident in actually doing signal phase changes and just being like, it's a green for all the bike riders and it's a red for all left turning traffic. And it's a red for bike riders and it's a green for heavy vehicle. So in those scenarios, if you were, if you did have a heavy vehicle network that was doing left turns, you might look at signal phases changes as opposed to just protected intersection because, yeah, it unfortunately takes such very, very little speed for a fatal to occur between a heavy vehicle and a bike rider, like 10 kilometers an hour, and that's kind of enough. Great question, though. Got another example. This one is out of Manchester again, out of the UK, and it's got a funny name. It is called the Cycle Optimized Protected Signals Junction, which is Cyclops abbreviated. So if you just type in Cyclops Junction Manchester, you'll come across this one. Implemented a few years ago now. Very, very similar properties to what we were looking at before. So we've got our protected, so we've got our corner refuge islands implemented at each quadrant. And then we've got, the bicycle facility that is being proposed at the adjacent area to the carriageway there. The reason I've included this one as a little bit of a thought piece as well is just to make mention of these gigantic head start boxes. So these bike boxes, depending on which jurisdiction you're in, we do use them in Australia. Victoria uses them quite frequently. Other states less frequently. But the idea is if you're at the intersection, bike riders can kind of filter up and then put themselves in the bike box to, be more visible and to get the head start at the intersection and things like that. Now, technically with a protected intersection, you wouldn't need to provide this because you're providing the protected opportunity instead. However, in this scenario, there was a bit of a understanding that not all bike riders are going to use the protected facility. So just to demonstrate why bike riders may not, if you were wanting to turn right, traveling from the left of the screen, this is kind of your movement here. You get stopped at this signal. You wait for your green. You get stopped at this signal. You wait for your green. And then that's you on your way. When you look at it this way, and I'm just talking about it casually and just drawing things with my finger, it doesn't sound like the end of the world. But for those riders that are in the very confident and capable brackets, that's quite circuitous. And it's just not the way that they would prefer to travel. And this design kind of acknowledges that and says, well, we're not going to force you to use that. Instead, if you want to just treat this as another signalized intersection, you can. We're going to give you this massive bike box. You can position yourself there. Once you've got the green, you could enter this right turn traffic lane. So that's not a right turn bicycle lane. That's just a general traffic lane, which a bike rider may be able to use. And then this is an example of filtered traffic signals. So the red drops off. If you've got a gap in the traffic and you feel confident and you can make that call, and you can then do that right turn like that. So this is a scenario where you've got the protected intersection. For those that don't feel comfortable in doing that right turn that I've just drawn there, which is probably more common. If you don't feel comfortable doing that, we're certainly not forcing you. There is the protected intersection. And vice versa, if you don't want to use the protected intersection because it's going to take you longer and you just want to get home or you want to get to work, whatever it is, we're not going to exclude you from actually utilizing a more conventional way to turn right there. There you go. So that one's out of Manchester. This is what it looks like on the ground. And actually, I'll skip to the next one so we can have a look. The one thing that I make a note of for this is where pedestrians are crossing in this instance. The way that they've highlighted the conflict point is using yellow. I'm not sure if that is a common practice in Manchester. It's not something that I've really seen there before, but that's what I'm talking about. That's where I'd be instead recommending, let's do a zebra crossing. Just so as bike riders are approaching here, they know, all right, there's pedestrians here. I need to slow down and give way to them because they have the priority. So that's where you'd install those zebra crossings. The other unusual thing about this example is in all the previous ones, the pedestrian and the cycling facilities are flipped. They're around the other way. So it's usually, the bike riders are on the inside of the intersection and the pedestrians on the outside. This way, it's a little bit different, and you're kind of forcing the pedestrians to cross into this little, I'm not even sure what you'd call that, like a little median or holding zone before crossing over. I don't think there's a benefit either way. I think the ways that were looked at previously are more conventional, but that's the approach they went for this example. Alrighty, so we'll have a chat now, something that will be a little bit more familiar, because we're using standards and guidelines, that something that we all have to reference. So this one is out of Melbourne, and I'm going to focus on the southwest quadrant of this intersection. On approach to the intersection, it's a bit difficult to see. This is a very zoomed out image. See if I can zoom it in just at this location. We've got a nice, beautiful park, a footpath, and then a protected bicycle lane, a very, very narrow separator, and then a parking lane. Yeah? So there is a little bit of a protected bicycle lane, if you could call it that. It's not very protected at all. But anyway, if we're riding up to this intersection, we can see, although that tree is very inconveniently covering it, but the bicycle lane just tapers off. It just ends. That's a very, very common approach to deal with cycling infrastructure. If you don't have space at the intersection to provide a bike lane, bike lanes just drop off. It's super, super common to have historically have done that, and it's all over the network. So that's a big one that we can like automatically identify as a risk. We can't just be dropping off bike lanes and assume that they're going to safely pass through the intersection. We need to maintain that connectivity. Anyway, we've got the bike lane there that drops off, and then our stand-up lanes, and the stand-up lane is just the approach lanes in this example of the intersection. The stand-up lanes, we've got a left turn dedicated, we've got a through lane, and we've got a through lane and a right turn as well. There's no arrow for it, but it's right turn permitted as well. So that's how things looked prior to any intervention. Give you a bit of a look of 50-50 so you can see how things have changed. I might zoom in again because it made it easier for me as well. What we've got now is the protected bicycle lane leading up to the intersection. It remains protected. So you can see there are some separators that have been installed all the way to the intersection. So it's no longer just disappearing. It's being maintained to the hold line. That has come at the cost of one of your stand-up lanes. So previously we had 3 stand-up lanes. Now we have 2. We've got a left and through and a through and right. It's pretty common with protected intersections to have to eat up a stand-up lane. That's generally where the additional space comes from. It's reallocating one of the traffic lanes to be able to maintain the cycling connectivity. If you did have a large footpath area, then perhaps you wouldn't be required to do that. But to me, if you've got 3 traffic lanes and 0 bicycle lanes on approach to the intersection, it seems like a pretty reasonable sacrifice to give up one of those traffic lanes to make sure that you're at least maintaining the cycling connectivity through there. And this is what it looks like fully completed now, but you can see once again, corner refuge islands at each of the quadrants there. And yeah, this has been installed. Because this was the first one in Victoria, there was a lot of road safety audits and stakeholder engagement and lots of different peer reviews to ensure that this project was feasible. Although we know these things have been installed in other jurisdictions for many, many years, because this was Victoria's first, there was a bit of apprehension, which I'm sure we can all relate to. One of the items in particular that was noted to be of concern was the Corner Refuge Island. And this went through quite an iterative process. So I'll just chat you through what's going here. When the concept was first conceived, the Corner Refuge Island took on quite a small little baked bean shape. This was presented and then kind of workshopped internally as being like, I'm not sure that drivers would actually see that. And also, I'm not sure if bike riders will see that. So I'm not sure that's the right size for that type of feature there. So you can see we got to our second design iteration and we've made that larger there just to make sure that it is a bit more conspicuous and reduce the impact of nuisance hits. The third iteration that we've got is once swept paths checks were completed. You can see from the second one to the third one is much smoother. So that's just obviously accounting for the expected vehicles traveling through there and ensuring that their swept path movements are uninhibited. The fourth diagram that we've got, now we've moved into a bit of a boomerang shape. This was a bit of a discussion with the cycling advocate groups and recognizing that this is a very popular cycling corridor and that there is anticipated to be relatively large volumes of bicycles kind of propped and waiting to turn. So rather than forcing them to use the footpath to prop and wait or block the carriageway, they've narrowed that Corner Refuge Island to just make it easier to be able to stop and prop. The final one that we can see there is very, very similar to that previous one, but what we've actually got is some cut-throughs, and see if this works. No. Anyway, what we've got here is the shaded sections of the last Corner Refuge Island. Those are at roadway level. And if you were a very confident bike rider and you wanted to maintain speed, deviating like that, although it looks negligible, it would impact on your speed and it would maybe not be a very attractive thing for you to do. To mitigate that, they created these cut-throughs so you can basically deviate less. Now, gotta be wary of that because the less that we deviate, the less that offset is. And that's the point of the protected intersection, to create that offset. So you don't want to create too many of these cut-throughs or too wide of a cut-through. This was one where it just needed to kind of have that balance between, connectivity and maintaining the commuter cyclists' high travel speeds, but also trying to facilitate a safer crossing opportunity for those that are not traveling that fast. So that's why we've got that final iteration of this design. Now, actually, I might pause it there because I've got a bit more content to go through, but I think it might be a good time just to have a bit of a stretch and we can get started again in 4 minutes, okay? So go have a cup of tea, cup of coffee, have a stretch. I'll see you again in 4 minutes. Get a cup of tea, get a coffee, feeling good. Maybe pat your cat, pat your dog. Let's get back into it. So as I alluded to before, this one was a bit of a tricky one to get through project-wise. Bit of apprehension from different stakeholders, and to give all those involved in this project a bit more confidence that, this could work. It's not something that's too far reaching or too academic or anything like that. This could work on this particular site. What they decided to do was they drew a 1-to-1 scale mock-up of this intersection at a depot, so a completely off-site, locked gates and things like that, not open to the public. And they said, all right, stakeholders, let's not theoretically assume what it feels like to ride through this intersection. Let's give it a go. And so they got the stakeholders there on some bikes, and they got a test vehicle here driving and performing the left turn, the through, the right turn movements. And they got to have a bit of an experience of what it actually felt like with this infrastructure that would be implemented. So this is line marked. It's exactly what was being proposed. And all those stakeholders got that opportunity to, have a go of walking here as a pedestrian, ride through here whilst those turning movements were being performed in a safe kind of environment. So quite a unique example of stakeholder engagement. Probably not one that you need to do as part of every project, but yeah, just thought it was a pretty unique situation there. Something else just to touch on quickly that is quite common with protected intersections is having to relocate your hold line or your stop line. So although a conventional vehicle can quite easily travel around those corner refuge islands, if they're provided, as we've already talked about, there may be some swept path challenges for heavy vehicles or long vehicles, and what that may therefore result in is changes to the adjacent hold line or the stop line. So very important to do those swept path checks, not just so that they're not hitting any of the corner refuge island, but also to make sure that they're not, going to be striking opposing traffic. I've got this little snapshot that I've just snipped from a video. So this is me riding through the protected intersection and just kind of drawn out, I guess, the travel path. So the yellow line there is the conventional travel path. So this was just like a normal bicycle lane. So I'm heading through, and the taxi that's adjacent me, they're turning left. Now, a moment forward in time, this is what that scenario looks like, where as a bike rider, I need to be like, all right, the taxi hasn't seen me. I need to slam on the anchors because, there's going to be a conflict here. It's just, you can see I cannot make eye contact with the driver of that taxi. However, the protected facility means that I'm actually diverted out to the purple path that's shown there. And once again, a moment forward in time, and this is what my view looks like. The yellow line there is the conventional path, and that's the path that I'm taking. But if you look inside the passenger window there, you can see that the neck of the driver is very, very much turned and facing towards me. So it's absolutely demonstrating the reason that we are advocating for these facilities, because they have that ability to improve the sight lines for left-turn vehicles. It's also really important just to ensure that on approach to our intersections, we are also providing clear sight lines. I might skip over this one because I'll go to the next slide. It's important both from the perspective of traffic so that they can see bike riders and they're not surprised to see them, that they just pop up at an intersection. But it's also important for bike riders so that they can actually make decisions as to whether or not to head through an intersection, or if they need to slow and give way. So just a note there, if you're looking into protected intersections, what are the sight lines leading up to that intersection? Common things would be trees or bus shelters or, advertising, billboards, utility poles, all of those types of things can impact on sight lines. So what can we do to provide that as clear space? Alrighty, it's that time of day where I do get to ask the group the question of what's wrong with this photo. Got another confused cyclist there. I'll get her out of the way. And move the banner down the bottom. That was pretty jazzy. Hope you enjoyed that little bit of formatting. What's wrong with this photo here? And I'll give a bonus point if anyone wants to take a stab what country this one was taken in. So what's wrong with this photo and what country are we in?
Exciting stuff. Okay, we'll give everyone a second for some typing, although the USA is coming out on top.
Not the USA.
Oh, okay. Is it North America? Yeah. Hugo's along my line of thinking. Canada? Canada?
It is Canada. Well done.
Okay, great. All right, so we've got that. So it's not wrong that it's in Canada.
No.
That's not what's wrong with the photo. But what else? Oh, so we've got the traffic sign is unclear on who needs to go to the right of the raised island.
Pretty confusing.
Oh, the traffic sign, I see. That's just under the question mark.
That one? Yeah.
Okay.
That's just their way of signing that. Like that's a pretty common sign over in North America. We would probably use a hazard marker.
Okay.
Yeah.
So that's not what's wrong with this photo.
It's well picked up.
Okay.
If that's all we've got, we'll give a prize.
No, come on. I think people got something. So, okay. Signs in the bike lane ahead are blocking the way.
Oh, that's very well spotted. These ones?
That's what I was thinking. Yes, and bicyclists have to diagonally cross the intersection to continue on their journey. Is that right? Is that what's happening here?
That is what's happening there, and that is very, very unusual to see. So the diagonal crossing there. Sometimes we do it with pedestrians where we stop all traffic and we create like a scramble crossing or a Barnes dance, as it's called. But creating diagonal crossings can be a little bit of an odd thing to do because where you've got signals that are only facing the diagonal traffic, they could potentially be misinterpreted as the through traffic because you've only kind of shifting it 45 degrees. It's not like it's going to be completely obscured. So there's a bit of a risk of that. So well picked up there.
Good.
Some good
Pavement
answers
marking is a bit weird. And I'm not sure, Max, it's hard to see in your photo. We've got a bit of scribble on it now too. Is there pavement where that cyclist is in the middle of the intersection? Is there pavement marking indicating that am I seeing that correctly?
Those are all sharrows. So that's sharrows to be used as directional to say, follow this way.
Okay. Good. Great. Thanks. Good. Okay. A few prizes out there. Good.
Thanks very much. All right. Let's have a chat about head starts. So I briefly talked about this with the Manchester example. And within the cycling aspects of the Austroads guides, there is some actual guidance of when to apply the head starts. And what you're looking at is basically 4 different configurations that you could use these facilities. They don't offer a significant safety benefit. It's really just to give bike riders that prominent position at the intersection, but you're still kind of forcing them to, travel on the traffic lane. So it's not as to say that the head starts are going to be the massive resolution to all of cycling trauma. But just wanted to mention that we do have these things and we should be implementing them at intersections where we do have cycling corridors and cycling connections to help maintain that movement. the way that I kind of reference these different general arrangements, as I said, you can get all the details in the Austroads guide, but basically you can kind of consider the head start where it's being situated as a bit of wayfinding. So an example A, where I've only got the head start sitting just proud of the left turn lane. As a bike rider, what that's actually conveying is you may be able to travel straight, you may be able to travel left, but we're not really encouraging you to turn right because there's nothing there for you. So there's no cycling connection there for you. Example B would be like you're anticipating higher volumes and you're trying to bring the cycle lane conflict point prior to the left turn lane. So you can see that the cycle lane is like in the middle there, basically. Example C, I really wouldn't worry about it. This is not a common example at all. And it even says that in the Austroads guide. It'd be very unusual for you to kind of nominate that type of arrangement. It's much more common if you are supporting right turns as well. So if you're doing left, through, and right, just to do a big box across all the traffic lanes. So you'd go for that instead. Much more common to see example D than C. Before we get to that head start box, though, we need to think about how we can manage that left turn and through treatments. And I'm going to focus now on we don't have the resources to be able to install the protected intersection. Well, what else can we do? One of the examples is, as I touched on before, it is basically ending the bicycle lane, ending the formal bicycle lane, but installing sharrows in the left turn lane to hopefully communicate to drivers that you should reasonably expect bike riders to be here. And we want to encourage bike riders to sit in the middle of the traffic lane as opposed to push themselves to the curb and potentially get squeezed. Generally, when you have these arrangements, you may have supplementary signage to say that even though you're in the left turn lane as a bike, you can still travel through. So you can still just go like that and get back into your bike lane. It's quite common. Sometimes the sign isn't there and it's just implied, but legally with road rules, that signage needs to be installed as well. Another way that is quite common to manage this arrangement is to kind of bend the bicycle lane out. So this is a bent out treatment. And the bicycle lane is kept throughout all the way to the hold line. So it's maintained through there. And if you're turning left to access the left turn lane, you can see that the conflict point there has been highlighted green as well as all the way to the hold line, just to emphasize the presence of the bicycle lane and the presence of that conflict point. Both of those are certainly skirting on the edges. Neither of them would offer as significant as benefit as creating protected facilities all the way throughout, but those are two quite common ways that we manage bicycle treatments at intersections. One thing that I did want to chat about with either approach that you adopt is consistency. So got a signalized intersection here, and the east-west corridor is a popular cycling route in Melbourne. I used to ride this to get to work. My ride to work was west, and I'll just show you what my ride to work looked like. So starting from this side of the screen, there was an on-road bicycle lane adjacent the Dorig zone. It's a 50 km/h speed. It's not ideal. And then you can see I've got the bicycle lane just ending, and then the sharrows being implemented on that left turn lane. So that's how my connectivity is managed or maintained all the way to the hold line. And then a bike rider doesn't have to turn left there. They can continue through and they get to carry on through, and you can see the bike lane continues through that intersection. So that was my ride to work, and it's not ideal and not what I'm suggesting is what every intersection should look like, but generally not the worst thing that I've ridden through. And at least there's consistency that's been applied there. However, the reason that I'm demonstrating this is because my ride home from work was a different story. And although this is the same intersection, I've got same kind of approach. I've got an on-road bicycle lane next to the dooring zone. And when the bicycle lane ends, there's just nothing. So there's no sharrows, there's nowhere for bike riders to go. It's just assumed that you navigate your own way through here. And then it starts again at the departure of the intersection. It puts riders in a very kind of uncomfortable scenario because bike riders aren't sure is, well, should I just be going to the left lane, even though I want to continue through? Or do I have to push myself out and get into the through lane because I am heading through? So I think this is a poor example of if you are going to apply a treatment, ensuring that it's consistent at that intersection so that you've got consistency both from the rider's perspective, but also from the driver's perspective. So it's a similar environment. There's no surprises. You know what you're going to expect there. So ride to work, not too bad. Ride from work could be improved. When we're talking about slip lanes, this is where we can have elongated conflict points. So what we're looking at here is a conflict point that kind of exists all the way across here. If you've got bike riders traveling through and vehicles accessing that slip lane there. Because of the way the slip lane works, you need to create, the tapering and the actual slip lane length and all that type of things. They tend to be much, much longer than conventional turn lanes. And so you have much more exposure to those conflict points. It is pretty difficult to manage this any other way. In this scenario, I'm trying to think of the best way to word this. In this scenario, this is an 80 km/h speed zone. So this is not somewhere where I'd be recommending on-road facilities, period. But we've got them. And it's highly, highly, highly likely that the riders in that environment would feel comfortable traveling through there using that on-road facility. So Austroads does have a little reference of what could be implemented instead, which is basically, let's get riders off-road. Let's push them onto the adjacent footpath if you've got it. Let's get them crossing over the slip lane before rejoining that cycling connection. The benefit of this approach is you could actually create this as a raised crossing point then, to really bring down vehicle speeds at that conflict point, which is a big tick. The only reason I'm being wary of, I suppose, formally endorsing this is because if that were to be implemented and you expected all riders in this environment to kind of do this travel, as I mentioned, the riders that are here already are those super confident, athletes basically. And they're not going to do that. Like, it's very unlikely that you would get the majority performing that because it's well out of their way, and performing those tight right turn, right turns are just, it's very unattractive for that demographic. So if you were to exclude the provision of an on-road facility because you were just going to assume 100% compliance. I think that would be a naive way to approach this, and instead kind of reflect on what your environment is and what your expected levels of riding are. Now, if on the other hand, this was like a strategic cycling corridor and you were trying to make this a popular route for people aged 8 to 80, well, we shouldn't be doing any on-road altogether, and it should be maintained off-road kind of throughout. And that's when that Ostroad solution could fit in there. So need to be a bit sensible about how you approach things and reflect on the surrounding context there. All right, some hook turns, something that we're very fond of here in Victoria. Not so much other states, but hook turns can also be performed on a bicycle. A hook turn, for those that aren't familiar, it's just another way to turn right. It sounds counterintuitive, but turning left to turn right. And if you're a bike rider, it's actually quite a handy little tip to learn, because it can be very stressful sometimes to try and push yourself to get into a right turn traffic lane. And rather than deal with that stress, it can be much, much easier for you to just utilize a hook turn. So the way that that actually could be demarcated is through the use of pavement arrows and perhaps using some conflict paint just to highlight that. Got an example here of an intersection where every leg has a hook turn. That's what the hook turn actually looks like out on site. And just to, I suppose, draw it out when I'm talking how this works, if you're riding north or going towards the top of the screen and wanted to turn right, you'd be riding here, and then you can just pause and wait in that little storage box, hook turn box. You're not going to block through traffic. You're also basically got a head start now on the vehicle traffic going the adjacent direction. And so when you do get that green, you can then continue that movement. You're not having to push yourself to get into that right turn traffic lane and then potentially having to do filtered right turns. So yeah, big fan of hook turns, and it's a low stress options for right turns. If you're looking at that for a T intersection, you could actually include something that looks like this. This is like a bypass arrangement. And let's say we've got another cycling corridor that connects at this T, and we want to maintain that connection. Well, rather than try and get bike riders across into a right turn traffic lane, we can provide this little gap in the separation. You'd have to have like a pedestal there or something, just so there's a push button for a bike rider. I can push that button once it's a red for all. They can then perform that right turn movement. So that's an example similar to the hook turn, but it's actually being supported by the phasing, like the separate phasing. There is an example from Adelaide that I've dug out that kind of demonstrates this. It's a little bit different, but there is a bicycle facility. For those wanting to turn right, you've got an opportunity to do so here. You push the button, and you have to kind of do it in 2 phases though to get across there. That would still be preferable to a lot of riders than trying to get from here over into that right turn lane. Particularly if you've got multiple lanes, providing those bypass facilities can be a much more attractive option. I got sent this one from a colleague. It's not an example of an intersection or anything like that, but it kind of demonstrates the point that I was talking about before about turning left to be able to turn right. So in this scenario, you've got an on-road bicycle lane that is getting shifted to the other side of the carriageway where there's a shared path. So where all these people are on the other side, that's a shared path. And so rather than encourage riders to kind of just gun it and give it a go and push their way in front of traffic, instead it's saying, nah, come to the left here and then store here and wait, pick a gap in traffic, and then once you're good to go, then you can cross. So it's just another way to provide that opportunity so riders don't feel like they have to, take that direct path. If they don't feel comfortable doing that, you've got that opportunity to take that in multiple goes. All right, bicycle signals. So bicycle signals, what I mean by that is just the bicycle lantern. So most commonly it's just the green. You might also see amber and red, but conventionally just the green. And the way that they work is you see the green and the bicycle rider gets the head start. So they would conventionally get anywhere between a 2-second to a 5-second head start at that intersection. It's a little bit of a safety thing. It's more of a level of service and improving the attractiveness thing. So it can certainly be a safety thing if you've got, if you're able to clear all of your cycling traffic before any of the left turn movement starts, then I'd say it's definitely a safety thing. But anyway, there's one installed at this intersection, and as you can see, there's a lot going on at this intersection. We've got service roads. We've got 1, 2, 3, 4 traffic lanes. We've got light rail that's being in right in the middle there. There's heaps going on. And where I'm going to focus on is the bottom of this intersection. You can see that there is a bit of a head start box there for bike riders. There's also the bicycle signal, or that head start lantern. I'll show you what that one looks like out on the ground. And this is another one that I'm speaking anecdotally. And adjacent my traffic signal, it's a bit difficult to see with the contrast of this photo, but you can see kind of tapped onto the side of the traffic signal. That's the bicycle signal. So there's just a single aspect. There's only one light and it's green. You can also see the conventional traffic signal. There's no right turn arrows as well. Something to note. So filtered right turn is permitted. I was riding through here one day and wasn't overly familiar with this area. And this actually looks a bit different now. This is a bigger box now. Anyway, I wanted to turn right because that's where my home was. I wanted to get home and start cooking dinner. When the intersection was at red, all the vehicles had stopped, and I get this green go for bicycles. I immediately start performing my right turn movement. However, the bicycle head start hadn't been set up in a way that you could actually perform a right turn in that head start vicinity within that time frame. So in other words, the head start had been set up just to give you a bit of extra time for a bike rider to head on through. It was trying to support the through movements. However, as mentioned, I was turning right. I got about halfway into this intersection when general traffic, they also get the green. And so I found myself kind of in the middle here, no man's land, when traffic either side of me starts streaming and whizzing past me. It's a pretty uncomfortable experience. But one of those situations where it kind of made me reflect as a practitioner of how you may envisage a specific treatment could be utilized and how you're kind of planning for it versus how a user may actually experience it or how they, you know, want it to work, basically. And so because my divan was turning right there, and there are cycling facilities on the right, so it was not insane that I wanted to turn right there. It's a little bit of a counterintuitive that I couldn't actually do that within the time allocated for that green for the bicycle signal. So something to be mindful of. Think about how potentially your designs, if it's got to do with signals or it's got to do with any type of infrastructure, how that could be misinterpreted. Maybe a good chance to chat to your family, if just run by them if they would have any issues interpreting this scenario and how they would react and things like that. Because once you do get heavily involved in designs and the ins and outs of all the different guidelines and standards, you just become accustomed to see certain arrangements and you know exactly how that's meant to function. But not everyone in the community has that experience, so it's good to do that sense check. This one's out of Perth, and they've actually got the aspects for the bicycle signals kind of embedded into the traffic signals themselves. So you can see it's just one clean face. It's also provided at kind of each signalized intersection. Really, really good if you're a bike rider because you kind of get this through movement priority being awarded. So if you ever stopped at a traffic signal along here, you're going to get the head start and you get to kind of travel on through. So it's actually, for the most part, quicker to be riding through CBD with these types of arrangements than going via car. All right, we've managed to get through the content quite efficiently today, but there's a few bits and pieces that I wanted to go through. So we will have a chat about our quiz that we'll have to get through at the end of today's session. And next session, we will be focusing on roundabouts. We could have included the roundabout discussion as part of today's module because a roundabout is an intersection configuration, but there are specific risks associated with roundabouts for cyclist safety. So decided to kind of separate the two just to elevate and articulate those risks. Got a photo here, another one of some temporary traffic management with this idea of bicycle lane just being closed and, forcing riders to merge right. Ironically, this was the setup as part of that protected intersection in Melbourne. So although they were installing a future, case scenario where there was a very pioneering cycling safety project, during the construction of that project, there was some desirable elements for the safety of bike riders. There was no detours set up there. And I think that's really, really important to note as part of your projects. How can you maintain that accessibility for bike riders and thinking about detours and things like that? Something that just caught my eye with this photo as well. Just on that sign there's a hook turn sign. I didn't actually know we had a sign for it for bike riders. So bike riders are basically being told that don't worry about getting to the right turn lane. Stay in your lane and just do a hook turn to turn right. There you go. The more you learn, huh? But in this scenario here, what I think could have been investigated was, can we actually utilize the sidewalk or the footpath here just to temporarily maintain that connectivity all the way to the intersection? Because closing it off and just saying merge right, probably not going to work for a lot of riders that are currently in there. All right, so just some bits and pieces to tidy up for the rest of today, and then it looks like I'll be able to give you some time back at the end of today's session, which is good. I've got another 360-degree video for you to go through, and that one's going to be focused on today's topic of intersections. You will get to have a ride through Melbourne's protected intersection, so get to give that one a go, which is exciting. And the other example is doing a right turn via a hook turn. So if you've never tried that, there's your chance to give it a go with a 360 video. We've got the quiz at the end of today's session as well. So similar to module 1 there. If you haven't completed either of those, now's a good time. Similarly, if you haven't finished assignment 2, good time to get stuck into that one as well. So there's only a quiz for today's coursework, so nothing too onerous. But I did just want to show another example of a cycling facility that I didn't include in our presentation. And this one's out of Toowoomba, and it's quite unique. It's another example of the left turn lane kind of going across the bicycle lane. Maybe I'll go closer to the intersection hold line so you can see it a bit better. So the bicycle lane continues through because that's where the cycling strategic corridor is. But certainly the demand from traffic flow perspective is this left turn. So it's quite an important left turn. Prior to this intersection, though, riders were not in this in-between situation. They were riding on the curb side. So they were riding quite close to the dooring zone. So if I go back up a bit, I have to go up a bit more than this. You can see that riders were in that dooring zone. So the way that this specific site has managed, how can I get the left turn traffic lane across the bicycle lane and how can I bring the bicycle lane out? It's quite unique. I haven't seen another example of this. They've basically just created a very, very wide area to show the conflict point for bike riders. And what they're actually encouraging, they're saying, bike riders, I want you to go from here diagonally and get across to this area here. And the way that they've done that is just a nice big blob of paint. By no means is this a perfect case or anything like that. It's quite unique. I haven't seen anything like this. But that's how they manage that in Toowoomba. And then if you're, just riding and continuing straight, you've got this facility now and you're no longer having to worry about left turn traffic coming across you there. So just wanted to share that. If you've got any other interesting sites that you wanted to share at the end of next session, please do let me know and I can include that as part of the session. But other than that, I've gone through all my content. So are we happy just to wrap up a bit early and give everyone a bit of time back?
I think so, Max. I quite liked your unique demonstration there. That was a bit of fun, and we're getting a round of applause. So I think everyone's happy with that. And yes, I guess if you see weird and wonderful things out there, do share them because good to see. I think
that's it. Great.
Thank you very much, Max, and thank you everyone. And we'll catch you on Thursday for the last session.
See you on Thursday. Take care, everyone. Bye.
Thanks. Bye.